right, guys, this is Mrs. Lyons, and today we're going to add to what we know about double replacement reactions. Okay, so I'm going to give you just a couple of steps. Some of this we've already done. Okay, we've already written out the products of this type of reaction. Okay, so we're going to do a reaction. Our example is going to be barium nitrate and sodium sulfate. The questions on the top are just a little review to make sure you remember about crisscrossing charges and what Roman numerals and polyatomic ions mean. I'm not going to go through that right now in this video. Okay. So what we're going to look at, okay, we're looking at a double replacement reaction. Okay. The generic formula for a double replacement reaction is we have two compounds, AB plus CD. And what happens is the anions switch places. Okay. So if you notice, as I write my products, one of the key things to keep straight in this is in our reactants, A and C are listed first in the compound. And in our product, A and C are still the first element listed in the product, okay, in the compound. Which means if you look at this, basically D and B switch places. Okay, so if we look at this example, barium nitrate plus sodium sulfate, the first thing I want to do is underline. So I'm going to rewrite this. Barium nitrate. The anion is the second part, okay? It's the negative part. So barium nitrate, the anion is nitrate. And in sodium sulfate, the anion is sulfate, okay? So what we're going to do for our products is we're going to switch those, okay? So what we end up with, and I'm going to write the whole reaction. So we've got barium nitrate plus sodium sulfate react, and our products are going to be barium sulfate plus sodium nitrate. Okay, so you just are going to switch the anions. Okay, now the second thing that we have to do, hold on, I've got to get my solubility chart. The second thing that we have to do once we've written our products, okay, it turns out sometimes double replacement reactions don't happen. And we have to look at something called our solubility rules in order to figure out if a compound, if a reaction is going to take place. Okay, so what we need to know, and you will have access to this for quizzes and tests, soluble compounds. This means these are compounds that dissolve in water. Okay, so in terms of the state, they would be listed as aqueous. Okay, so all group 1 metal cations are soluble. So if it's got a group 1 metal, so that would be lithium, sodium, potassium, what else am I forgetting? Rubidium. Any compounds with those three or those metals in them will be soluble. Okay. Also, any compound that contains ammonium will be soluble. Any compounds that contain nitrate, chlorate, perchlorate, or acetate will be soluble. Any compounds that contain chloride, bromide, iodine will be soluble except silver, mercury, and lead of those compounds. So silver chloride, silver bromide, silver iodide. And then fluorides will be soluble except magnesium, calcium, strontium, barium, and lead. All right. And then all sulfate compounds will be soluble except calcium, strontium, barium, and lead. Okay. Then we have a list of some insoluble compounds. Okay. And these compounds are always going to be insoluble, unless, of course, they're combined with a group 1 metal or ammonium. Okay. Carbonates, phosphates, oxalates, chromates, sulfides, oxides, hydroxides. Okay. And notice this little note says compounds that contain these anions are soluble if they contain a group 1 metal or ammonium. So let's look at what all of this means for us. Okay. So we need to find the solubility rule that applies to the products. Okay, so the first product is barium sulfate. So let's see, I find sulfates on my solubility table. It says all sulfates are soluble except, and there's barium. Okay, which tells us that barium sulfate is insoluble. Means it does not dissolve in water. Okay. And then our second product is sodium nitrate. Now, you should get to the point that you look at some of these and you see, oh, look, sodium, that's a group 1 metal. Okay. So remember, any group 1 metals are always soluble. And if that wasn't enough, nitrates are always soluble. Okay. Which means sodium nitrate is going to be soluble. All right. So when we're doing this kind of reaction, if one of our products is insoluble, okay, we're then going to go ahead and write this out as a chemical formula. Okay. If there isn't a soluble compound, like if these are, insoluble, if both of these are soluble, that means we have no reaction. Okay. But let's go through this one first because we do have an insoluble compound. So I am going to be looking at these compounds. Okay. Again, this should be old news by now. You've got to look at the charges and crisscross. So barium nitrate would be Ba NO3 Okay. And I'm getting ahead of myself. The second one is sodium. Sodium's +1. Sulfate is a polyatomic ion -2. So Na2SO4. Those react to give us barium sulfate. Barium's +2, sulfate's -2. So those cancel. BaSO4 plus sodium nitrate. Sodium's +1, nitrate's -1, so we get NaNO3. Okay. Now, and I will rewrite this, but the next thing to do, and you can probably do this all in one step, once you know what you're doing, add the states of matter for each reactant and product. All right. All reactants will be aqueous. Okay. And that's because if they're not aqueous, they're not going to react with each other. Okay, so my reactants, so I'm going to have BaNO3 2 aqueous, means dissolves in water, plus Na2SO4 aqueous. Okay, and then for the insoluble products, so for barium sulfate, I have BaSO4S. That means solid. Okay. And what you'll see, and we saw this in the lab where we formed that cloudy, what we call a precipitate. That's a solid. All right. And then for the soluble product, we would have NaNO3 parentheses AQ, which means that it is soluble. Okay. So that's how you write the double replacement reaction. You just have to add the states of matter based on the solubility from the solubility chart. Okay, and then we need to balance. And this one's not bad because if you look, I've got one barium on each side. I've got 2 nitrates, so I'm just going to go ahead and put a 2 here. Okay, so that balances my nitrate. I've got 2 sodiums and 1 sulfate. So my final balanced equation is BaNO3 2AQ plus Na2SO4AQ produces BaSO4 solid plus 2 NaNO3 aqueous. All right. So we've just added a little bit more to what we already knew what to do. Up next, we are going to talk about net ionic equations. Okay, that will be in a separate video. So I hope this helped, and I will see you in class. Take care.